this time around, we're going to have a look at this 1084 monitor that I've got here. I picked this up a little while ago, and I've had the parts, I just haven't got around to fixing it. It's popped a flyback transformer. So yeah, we'll be ripping this apart again in a minute and doing that repair. And hopefully that's all that's wrong with it. And the output transistor that drives the flyback as well, I believe, is a common failure point. So I've got one of those to replace as well. Of course, while we're in there, we'll have a look for the obvious swollen and pregnant capacitors and things like that, but I don't intend replacing any unless I see anything that's a little bit untoward. So yeah, let's get into it. So I believe the 1084S-P1, I believe the P indicates that this is a monitor of Philips construction. So yeah, I think the alternative construction was, I think it was Daewoo from memory. Anyway, so the screws are already out of this. They've been out of it for months. So this back cover should just pretty much slide off. And everything is already disconnected. I didn't disconnect it. The previous owner disconnected it. And we've got a few loosey-goosey bits hanging around in here. So when we put this together, we're going to have to work out where everything goes. You can see it's a bit on the dusty side. Oh yeah. So just give it a rough wipe off. So we've got the neck board here, which we'll take off so that we can try and avoid doing any damage to things. And this is where our flyback lives, over here. And the transistor that we need to replace, I believe, is attached to that heatsink. So we're going to have to get this do we have to get this circuit board out? It's probably helpful if, I don't know whether it's just going to slide out or not, whether it's still attached. It's just slightly attached. Oh, I see, it's held on by this connector here. Black to the back. So now I'm figuring this will mostly come out. Okay, we can disconnect the earth from the tube, making sure I remember to hook that back up. And that's polarized. So that's pretty much, except for that cable tie, it's pretty much got us separated from the tube itself. So have a quick just scout around the board and just see what's here, see if we've got any obvious leakage or anything silly like that from any capacitors, or any capacitors that are bulging, or God, needs a good blowout. That'd be an inductor, I imagine. It's an interesting suspect there because it's right next to something that's attached to a heatsink, and heat usually doesn't agree with these things, with capacitors. But I'm not seeing anything obvious leaping out at me. I think we're probably okay. Right, so This is our shiny new flyback, which hasn't even been out of the box yet. So that's that. And here's our transistors. Okay, so we got to get this heatsink out of here. So do that clip. That's obviously the first bit. Then what? Not quite sure how this comes out. Or do we leave the heatsink there? And yeah, maybe we do. Just pull the transistor out from, yeah, the transistor's free, so we can just work around that. So, turn on the desoldering gun. I'm not quite sure the tip's going to be big enough for this, but we'll give it a go. Right. No, the tip's not big enough. We'll just have to... the bulk of the solder this way. Right, so what we got? Oddly enough, that actually managed to get it all. I wasn't expecting that. Right. So get our new part, make sure our... Interesting. They're different parts. I will have to do a quick check and see if they are equivalent. Okay, so it turns out the BU508A is pretty much a replacement for the D1577, at least as far as I could tell from the data sheets. But the catch is the 1577 is a plastic case. The 508 has a metal backplate on it, which is connected to the collector, and that will be a problem. So I'm going to have to find something to sit between the back of this transistor and the heatsink, which is both insulating but also heat conducting. So I'm going to have to do a bit of digging on that to find out what best to put behind there. I've put a little hole in the heatsink for the purposes of attaching this transistor through its mounting hole. Not that it particularly needs it, because it's got this clip here to clip it in place, but putting the screw or the little bolt through it, at least even loosely, will at least stop the heatsink from, oh, sorry, not the heatsink, stop the insulator from sliding out underneath it and creating a short circuit down the track. So I'm going to have to find something to do that. So in the meantime, I thought I might see about putting the flyback in. Which is interesting because there's a lot of pins and it's hard to line them all up all in one go. I've got two pins up in here. Spread the heat around. Takes a fair amount of heat because there's some pretty big pads this is being soldered onto. Yep, those look all right. So the new flyback is in. We've got our anode cable. I've got to do some digging and find out where these two go. Because I didn't pull the monitor apart. Because I didn't pull it apart, I don't sort of have memory of where everything came from. So I'm pretty sure one of them goes to the neck board, but I'll have to do some digging and work that out. I've still got to sort out this transistor down in here anyway. Okay, so a couple of days have passed and some things have arrived in the post. So I've got some insulators. There should be 10 of them in there. And yeah, they'll hopefully keep our transistor case from shorting on our heatsink. No, they're just all of them. So we'll assemble. I might put, these are they feel very thin, so I might put a couple of them under there. Oh, I'm sticking my finger. So these are thermally conductive insulating, thermally conductive insulating pads, tabs, whatever you want to call them. Thermal film interface products. So the plan is that will go through there, that will go through there, just for a bit of extra thickness, the second one. And then we feed this. This is going to be interesting. I'll feed this through the board while holding this all together. Into the board. Now I've just got to get the screw into the hole. But we dropped one of our insulators, so that's no good. Let's try that. Fiddly. Try that again. Where'd that go? Oh, stuck to me. That's where it went. There we go. Before we tighten up, just make sure those are oriented appropriately. We don't want them sliding out from under there. Now, just for a quick sanity check, we'll just make sure that our collector isn't shorted to the heatsink. Nope. Interesting. Nothing on there. Our base has got very low. What? Our base and emitter have very low resistance to ground. Okay, so it looks like those resistances from the emitter and the base are actually right. I'll pop up an extract of the circuit diagram in a sec, and you'll see what I mean. But yeah, the emitter is tied to ground, and the base is through a 2.3 ohm resistor, then through an inductor and looks like one side of a transformer to ground. So yeah, that's expected. So we'll solder it in. This one's got a big copper pad. Right, we should be good there. Side. So just got to put this little retainer clip back on. This just holds the transistor up against the heatsink. There we go. He's clipped in. So the next thing is going to be to make some room here and hook this up on the bench, power it up, and see if we can get anything out of it. Okay, so this is my least favourite bit. My least favourite bit being plugging this in for the first time and hoping it doesn't go bang. I've got it plugged in through an isolation transformer that is sort of over there. It's out of shot, but yeah, a little 150 watt isolation transformer. So more for my protection than anything. So the switch should be in the off position, and we will plug it in. Well, that didn't go bang, so that's a good sign. The moment of truth. Is any... Oh, there's no smoke out of it. And if we look over here, oh, okay, so it's not happy about something. Okay, so that's likely flickering quite badly on camera, but in person it's just almost like a regular amount of CRT flicker. So the issue turned out to be quite simple. On the new flyback transformer, there's a couple of potentiometers on the back of the flyback, which I'll put a picture of up on the screen. But the top one's focus and the bottom one's like this level of screen drive, and as they come out of the box they're wound up way too high. I'll turn it down about there. Then I can turn the brightness knob up. That's half brightness. That appears to have got it sorted, so that the next thing's going to be to find a decent computer, like maybe the Amiga over here, if I can find some software, like a game or something to throw on it. Okie dokie, so we've got the monitor loosely back together. Don't have the outer case on yet, so I don't have the speakers hooked up to it or anything like that, but the monitor itself is back in one piece. So yeah, we'll power it on. And we're not going to see anything here because it's got no input signal at the moment. And I've got an Amiga over here. We will turn that on, see what we get. So it clearly needs a few adjustments. The image is The image is not very centered on the screen, and it looks like it could do to be stretched vertically a little bit. But I'll wait until my test pattern generator arrives, hopefully in a few days' time, and then I'll take care of that. Okay, so my pattern generator's arrived, and I've got that plugged in, generating the crosshatch pattern at the moment. So we'll start looking at adjusting this this monitor. See if we can get the image in the correct position for a start. I'm not sure, I can never remember which control is which on the back. Okay, that's vertical. And looks like we need to stretch the vertical a little bit. I think. It's hard to say. Of course, it's all very well to set this with the pattern generator, but it's no doubt going to get tweaked again as soon as the computer gets plugged into it. So that's our width, and our horizontal position is on the front. Now this one's a little funny because you can see over here on the side that it starts to roll over on itself if you adjust it too far. So we don't want to adjust it that far. So I'm thinking that's probably ballpark about right. Now if we go to, that's a full white screen. And we have no colour. What's going on here? Colour. Where are we? Colour. There we go. Turn the colour up and we'll get colour. So we go blue, green. Oh, that's magenta. Where'd my green go? Green. Blue, magenta. Now we can go colour bars. Which, I'll get full field. So that suggests to me that the image is slightly too far to the left. It probably wants to be around there somewhere, would be my guess. What does that look like? Yeah, that sort of looks, yeah, maybe. What? How do we lose our blue way off? Okay. Those are clearly very different. So, is our width too wide? It's supposed to be something like that. But then we're way off the side. Assuming this is not supposed to have a black bar. I wonder if it is. Crosshatch look like it. Crosshatch looks all right. I think we're going to be in the ballpark, so that's a good start. So I'm thinking the next thing to do with this monitor is going to be to give it a quick scrub because it's a little bit dirty, a bit grubby at the top and a bit grubby down the, yeah, sort of down in here in the where the controls are. It's a little bit grubby, so we might degrub it a little bit and put it back together, and then we'll hook it up to a computer and see how it goes. thinking I might take the speakers out. If I take the speakers out, then I can literally just dump this in the sink to rinse it off. And let's just pull out. There we go. There's all the electronics out of it. Now we've got to get the back of the case on, but we've got to make some connections first. So we've got to plug this cable, which is the audio cable. It's got to plug in here. So that's the first one. And then we've got to plug this ground cable in into point M10, which is over in here. Pretty sure. Right, so that's got our speakers hooked back up. Now we've got to very carefully shuffle this back together. Right, I'll just get my padding to sit on the bench. We should be able to stand it up. Not quite sure what's obstructing that at the moment. It could be these wires getting caught under this, just here, getting caught under this foot. Take them up that way. See if that helps. Bingo, that was it. The wires were just getting caught. Right, now I've got some screws here somewhere. A little tub with a label in that says 1084. Now what's this little black one? 1, 2, 3, 4. We've got an extra. Okay, so I think I found where the fifth screw goes. Probably get this front one, maybe. These back ones are going to be tricky to get into. The screwdriver doesn't fit down there. Okay, I'll just have to try a different one of these because it might work. I do have longer straight screwdrivers, but I don't have any longer Phillips. Last one in over here. Right, little one belongs right in here. Let's find a video source and see what it looks like. Okay, so I've got the monitor plugged into a computer, a Spectra Video SV328. So let's power it on. Give it a sec to warm up. And we'll flick the computer on. And we've got that sort of rolling dark bar, but that's just the camera being out of sync with the monitor. So now we can tweak it a little bit to suit how we like it. But yeah, it's back to life again. So I'd call that a win. So that's it for this video. We've got the 1084 working again, replaced the flyback, replaced the drive transistor that drives the flyback, and got it working to the point where I can happily use it again on some of these computers I've got here. That'll enable me to move forward with a few other videos that I've been waiting on a composite monitor for. And I've still got the 9-inch Apple monitor to finish off. That's still waiting on parts. Surprisingly enough, the most basic parts like capacitors are somewhat difficult. Well, not generally difficult to get, but particular types of capacitors are seemingly hard to get. And I've got another project I'm working on that for an upcoming video that's waiting on what would normally be a quite common 74 series logic IC that's proving difficult to find. So I may have to come up with a workaround for that yet, but we'll see. Anyway, if you like this video, feel free to subscribe, tap that like button, and yeah, maybe we'll see you on the next one. Cheers.